Hey, welcome to Mr. Berkey's Math Cast here. I'm just sitting in my room thinking about mathematics and wanted to share this with the world. Today we're going to be working on discontinuous piecewise functions and learning how to write the function given the discontinuous piecewise function graph. So before we get started, I want you, the viewer, to take a moment, maybe pause the video, and write down the differences and similarities between graph number 1 and graph number 2. Go ahead and do that right now. Take about a minute to do that. Alright, I hope you took your time to do that. You'll notice in the first graph here on the left that this graph is discontinuous. Might also notice that's finite. It doesn't go on forever in either direction, left or right, or up or down. We notice that it has a positive slope and a negative slope. And we'll notice also that it's discontinuous actually here at x equals 0. So discontinuous at x equals 0. Now over here on the second graph, or graph number 2, which I'll do in red, we'll notice that this is continuous. And remember that continuous and discontinuous, for a function to be continuous, all that means is that you can draw the graph and you don't have to pick up your pencil ever. So I can just draw this graph, ever having to pick up my pencil. But this graph over here, if we were to draw it, I'd have to pick my pencil at x equals 0, pick it up, move to y value 5, and move back down. We discussed this already, but that's just a friendly reminder. So this is continuous all the way. It's finite as well. And it also has a positive slope. And it seems like it changes to a slope of 0 as well. So slope of 0 as well. And there seems to be something happening here at x equals 2. So x equals 2. We'll call that a corner. That seems to be a corner. Yeah, we learned that yesterday. We call that a corner. That we call these endpoints. Corner endpoints. And that's just to get our brain warmed up. We're going to be dealing with this graph today and writing the function given this graph. So we're going to move down and begin to write a function giving the graph, and we'll call this graph f of x. So this function here is f of x. We know from before when we worked with continuous piecewise functions that the first thing that we need to do is identify our endpoints on our subfunctions. And we said corners and endpoints before, but we're not dealing with corners because this is a discontinuous graph. So there's no corners on this graph. There are just endpoints because it's discontinuous. Our first endpoint, and we'll identify all the endpoints on the graph and then just find the slope of the first subfunction. Our first endpoint is at the point over to the left 2 and down 7. So it's -2, -7. Our next endpoint is at the point 0. You're standing right there on the x value of 0, up 3. So 0, 3. Our next endpoint is the point 0, 5. And the last endpoint is 2, 1. After we've identified all of our endpoints, our next step is to write the domain of the first interval that we see. So the first interval that I see here is going from left to right is the interval that goes from -2 to 0. Now where did I get -2 and 0 from? -2 and 0. And I get that because these are the x values of the endpoints. So let me get a highlighter for you color freaks out there. These are the x values of our endpoints of this first interval. And we're just going to fill it in. You know, the x has to be greater than or equal to. And it's equal to because of the closed dot. And you know, this is going to be less than 0. And it's open, so we know it's going to be no equal sign underneath. Great, we have our domain of the first subfunction, so I'm going to begin to write our piecewise function, and we know that the first domain, we don't know the function yet, but we know the domain is from -2 to 0, and x is not equal to 0. Next step in writing the equation from the given piecewise discontinuous graph is finding the slope of this first interval. The way we're going to do that is just use our slope formula that we've been using, right? We're going to take the endpoints. We're going to get 3 minus a -7 over 0 minus a -2. That's going to give us 10, because 2 negatives make a positive. 3 plus 7 is 10. And then at the bottom here, remember, 2 negatives make a positive. That's a 2. And our slope is actually equal to 5. So we have our slope. Let me circle that. We have points up here. Remember, we can use point slope form to, or rather point slope formula, the point slope formula to graph or to get the equation of this first interval. So let's do that. And I'm going to use the point 0,3 just because I like to see that 0 in there. It might make things easier. I don't know. So y minus, and that y value is 3. So y minus 3 equals our slope, plug our slope in there, 5 times the quantity of x minus, well, that's 0. And then we're just going to put this in slope-intercept form. That's how us mathematicians like to write our linear equations. So you're going to add the 3 over, y equals, and 5. When you distribute that, you get 5 times x. 5 times 0 is just 0, and then remember we added this 3 over. So it's 5, y equals 5x plus 3. And listen, that's our first subfunction in our piecewise function. So I'm just going to write 5x plus 3. And you're going to use these steps to write this next subfunction. Same exact steps. And the steps are, let's see if we can go back and identify our steps. I'll use a different color for this. Just to remind you, our first step was to identify our endpoints and our corners, but we're dealing with discontinuous functions today, so we're not going to have any corners. Our second step was to identify the domain of the first interval or first function interval reading the graph from left to right. We did that, -2 to 0. Our next step was to then get a slope. And how do we find our slope? Well, we use the two endpoints, -2, -7, right here, 0,3, right here, and we just plugged it into the slope formula and got a slope. Then we used our prior knowledge of the point-slope formula, we have a slope, we have a point, and that's how we get our slope-intercept form of the equation. And then we just plug it right into this function, and we're on our way to writing the function given the graph of a piecewise discontinuous function.